Okay, now what we're going to incorporate into our application is pagination. And whilst at the moment our application doesn't contain a great deal of activities, but imagine there was 10,000 activities in this list. Currently we're returning all of them on every single occasion that somebody opens up the activity dashboard. And if they don't scroll down, then it's wasted bandwidth to send them this amount of activities. If there were 10,000 or 100,000 or 1,000,000, it would be irresponsible as developers to send all of that data back without knowing if the user actually needs it. So pagination is a way to solve that particular problem, and just about every application incorporates it. You wouldn't expect to load up Twitter and see 10 million items on your timeline. Of course, those items are going to be paginated, and it's only when you scroll down you're going to start seeing them. And that's the kind of pagination we're going to incorporate here because we've got a vertical list, and it makes sense for us to load things up vertically as a user scrolls down the screen. So that's the type of pagination that we're going to implement here. And what we'll do to start with is we're going to create the structure so that we can paginate anything that's a list in our application. And what we'll do, because this is logically going to take place in our application layer, then inside the application core folder, we're going to create a new class, and we're going to call it PagedList. Now, this paged list is going to be used for anything, any type of list in our application, so it's going to take a generic parameter. And what we're also going to do is derive from the list class that we get from the framework. So the list is also going to be a type of T, and we'll bring in system collections generic. That means our page list inherits everything that's available inside the list class, but we can extend the list to give it some pagination properties. So the pagination properties that we'll add an int for the current page. We'll add an int for the total pages. We'll add an int for the page size. And we'll add an int for the total count. And what we'll do is we'll add a constructor to this particular class, and we want to take the one that says generate constructor ... so it populates all of these properties as well. So this gives us a starting point, but what we'll do is we'll also take in an IEnumerable of type T, and this is going to be the items in the list. And we'll just change the parameters at the top. We'll swap current page for count, the total pages, we'll swap for page number, and we'll have an int for the page size, and we don't need the total count. And then the current page, we'll just swap this for page number. The total pages, we'll need to calculate this from the count and the page size. So we'll cast this to an int, and then we'll use the math class, which we get from system, and then we'll say ceiling, and then we'll work it out from the count divided by, and we'll cast the page size to a double and specify page size. So in the case that a list had 12 items and a page size of 10, then this would work out to be 2. The page size is going to be the page size, and the total count will just set to count. And what we'll also do is we'll create a static method inside this class that's going to allow us to create a paged list and return it. So what we'll do, and it will hopefully make more sense when we write the code for this, we'll say public static, and we want this to be an async method that's going to return a task of a paged list. And the page list is going to be of type T for whatever we're paging here. And we'll call the method createAsync, and we'll also need to bring in system threading tasks. Now the createAsync method, we're going to take in an iQueryable for this, because we're going to receive our list of items before they've been executed to a list in our database. So we're going to say iQueryable of type T, and we're going to call this the source. And we'll also need to bring in system.link to make use of that. We'll also take in the int of the page number and the int of the page size. And let's just bring that down. So what we want to do from this information, our source is going to be a list of items, or it's going to be a query that's going to go to our database. And what we want to do is get the count of the items before any pagination has taken place. That way we know the total number of items in the list. So what we'll do is we'll specify var count equals await and then source, and then we can say count async. Now this does execute a query to our database because we need to make this query to establish how many items are in the list totally. So whatever happens when we implement paging, we are going to be making two queries to our database, and the first one is going to be to get the count of the items before pagination has taken place. And then we'll get the items and we'll say await source, and in order to use pagination we tell it the number of items we want to skip, and we're going to get that from the page number -1 multiplied by the page size, and I'm missing the 1. So the idea of this is that, let's take for example, we have our list of 12 items and a page size of 10. Then in order to get the first 10 records, we need to get the page number -1, which is going to be 0, times by the page size, which is going to give us 0, because multiplying anything by 0 equates to 0. And for the second page, it will be page number -1, which will give us 1 times by the page size, which is 10, and that will give us the next 10 records. And then we use the take operator, and we want to take the page size. And then we can execute the query to the database by using toList async. So by using this method, we're deferring the execution. We build up our query, which is an expression tree that we pass to this method, and only then do we execute the database commands to go and do something and get the data back or count the amount of items in a list. And then from here what we can do is return a new paged list, and we can pass in the items, the count, the page number, and the page size. So this is step 1, and this paged list class is going to give us a paginated list of results along with the counts and the items as well. And we'll have access to these properties when we return this paged list. We'll be able to get the current page, the total pages, the page size, and the total count based on what's going on inside our static method here. And there's one more thing we need to add inside our constructor here, by the way, otherwise we'll return 0 items. We also need to add the items we get passed in as a parameter into the class that we're going to be returning, and the way that we can do that is by saying add range and then pass in the items. And then of course, as well as having access to all of the pagination properties, we'll obviously have access to the data that we're trying to return. So next up, we'll take a look at how we can paginate using this PagedList class our activities list from our handler.